Hi everyone, welcome to today's session. My name is Shri Krishna. I'm your learner success manager for the day. Before we go ahead with the session, please let me know if my voice is loud and clear. You can confirm in chat box. Let me do a quick audio check with our instructor. Hi Rahul, for audio confirmation, let me know if my voice is loud and clear.
Yes, Sri Krishna, you're loud and clear.
Yeah, we can also hear you clearly. Now I will make you the presenter so we can get started with the session. Happy learning everyone.
Okay. Hello everyone. Let's wait for a couple of minutes so that everyone can join in and then we'll start. So sharing a screen that will be starting shortly and I'm currently muted. Hello everyone. Good morning, good afternoon, good evening. I hope I'm audible to everyone. Okay. So just a verbal recap of what we did in your previous class. So we started with matplotlib and we were able to complete matplotlib in our previous class. And during discussion of matplotlib, we discussed various theoretical parts of statistics as well. What are various measures of shape, variability, and central tendency, and what is a linear relationship, and all those kind of things. So that is what we looked at. Okay. And then essentially in the last class itself, we started talking about CBON, another library that we'll be going through, and I gave you we went to the website of CBON, and I told you what is the difference between CBON and Matplotlib. And what we'll be doing today, we'll be talking about how to use CBON. So we'll be looking into the programming pieces for CBON library, in fact. So yes, we'll be doing that. Before moving ahead with that, anyone having any questions, please put in the chat. What is error? Like, how are you executing it? What is the kernel or what is the ID that you are using, Lakshmi? Okay, can you share the screen and talk? I hope I'm audible to you. Let me do one thing because this was the same error you had last time as well. So, can you share your screen, Lakshmi, and let me unmute you as well? Let's solve this error because same error is what you had last time. You mentioned that you'll be solving it by yourself. Yes, Lakshmi. We are not able to hear you, Lakshmi. Can you? I hope you're unmuted, Lakshmi, but we are not able to hear you if you're speaking. Can you share your screen? I might help you if you share your screen as well. If you show me how you try to execute a program, I might be able to figure out. I hope I'm audible, Lakshmi, correct? Using the share option in Zoom, Lakshmi. By using the share option. Lakshmi, do you have any a prior experience of IT, or your domain is completely different? Can you help me with that information first? So Pavitrata has shared a screenshot for you to tell you how to share the screen. You're also unmuted. I'm not able to hear you. We can have a conversation if you can uh, check whether audio is connected of your system or not. Okay, honestly, what I see as a issue, Lakshmi, that you're unfamiliarity with the systems or IT or laptop or computer systems. So what I would highly recommend, first of all, is for you to explore uh, a system or programs. When I say programs, yes, now I can hear you, Lakshmi. Hello.
Yeah, I tried so many times, but the programs are not getting executed.
Can you share your screen? Show me which program and how are you running it, so that we can kind of
I'm
solve
not
it.
able to get any of the graphs, and I'm so frustrated.
So you need to click on share screen. So that's what I am saying. Can you share the screen?
Just a minute. I'll try.
Mhm.
But it is in Simply Learn only, the practical class.
No issues, of course. Please share the screen. I'll help you with that. Lakshmi went on mute. Let me unmute you again. You can unmute yourself. I've given you the permission. Are you sharing, Lakshmi?
Yeah, I'm trying. Just a minute.
Mhm. You simply need to click on share, and then it
Yeah,
will show
yeah.
you all the windows that have been opened up in
Yeah,
your
just a
system, and then
minute.
you can select the window. Or you can share the whole screen as well. Lakshmi, if you can be a bit quick, that will
Yeah,
help.
I'm trying.
What is the challenge you're currently facing, Lakshmi? Means,
No, I'm not able to share. I cannot find that option.
can you open up the Zoom in which using which you have connected the call? I hope you're connected using uh, your laptop or system.
Yeah, laptop, but I don't have Zoom. I'm connected with the browser. That's why I don't find the Zoom option.
Okay. So can you install the Zoom app and then you can share after the like at the end of the class, in fact, is
Okay.
meanwhile you can install the Zoom app
Yeah.
and then log in using the Zoom,
Okay.
and at the end of the session then we can share the screen again.
Yeah. Yeah.
Okay. Perfect. Then let's move ahead then. Thank you, Lakshmi. Okay. So let's move ahead then. So let me share the screen with the Cbon code, and let's try to go through our Cbon library and go into further details. Just give me a second. I'll be sharing screen in a few seconds. I'm opening up the code. So I hope my screen is visible to everyone. Okay, perfect. So if you remember, we talked about the Cbon library. Let me also just open the landing page of Cbon library so that we have idea about it. Just give me a second. So this was the page that we have already gone through, correct? And I also shared this page link with all of you. So this is the Cbon library, in fact, that we will be talking about. We look quite, in fact, in many kind of things like how do you plot a histogram and so forth things, and how is it different compared to Matplotlib. So this is a library that I will be talking about. We'll be looking into the code now. We talked verbally about and kind of introduction to this library was done in previous class. So we'll be building on top of that. Okay. Okay. So, and let me also show the line numbers. So we're importing Cbon as SNS. So this is a common alias that we give to Cbon library. And for example, for matplotlib.pyplot, we tend to use PLT. For pandas, we tend to use PD. For NumPy, we tend to use NP. So same way, for Cbon, we tend to use SNS in fact. Okay, and this is a commonly accepted alias in fact that is given across the industry. So whenever if someone is using SNS, most probably it will be for Cbon. But just to mention that this is simply a nickname, you can give whatever name you would want to give. You, you can write anything when you want to import it as a library. Okay, so import Cbon as you can write give your own name as well. In fact, in second line we are also importing the matplotlib library. Just give me a second, everyone. To avoid an accidental unmutes, I'm uh, taking away the unmute capability. Okay. Then second one is importing matplotlib library, and third one is importing the pandas library. So what we'll be doing is we'll be using the same data that we use in matplotlib library, the tips data for our use case, and seeing how we can make graphs using Seaborn library. So this is exactly the same file that we are using for pandas and matplotlib as well. Okay, quite good, small and neat data set is. So now what you are doing, first of all, uh, like what does .curr give you? Can you tell me what is .curr, everyone? What does .curr gives as the output? Because we already discussed this in pandas. Correct. It gives us the correlation. And now what is correlation and what is the range? Can you tell me what is correlation and what is the range of correlation? So the range is -1 to 1. And what does it tell us? What about that? Can you tell me what does correlation tell you? Anyone? It tells you how is the linear relationship between any two particular variables. Correct. It tells you the linear relationship. Okay, so we are simply getting the correlation over here for all the numerical columns only. That is where numeric only is mentioned as true. That is what we are doing over there. And then we are getting this correlation matrix impact. Okay, this is identical through the diagonal. Okay, that is why you can see exactly same numbers in the top and same numbers over here as well. But still, this is how it gives you as output. Now, the first thing that we'll be doing is we'll be making a heat map on top of the correlation data or correlation results that we got as output. What is a heat map? Heat map is simply, you can say, a colored matrix like this, which can be drawn on top of any data. Okay, it can be drawn on top of any data. It's not, many people tend to relate heat map only with what? Only with correlation, but that is not the case. Keep in mind that heat map is an individual or independent graph. What does it do? You pass data to it, it will simply display a square or rectangle type of graph in which numbers will be showing the strength of the color essentially. So that is what is happening. So what I did, how to make a heat map, sorry, SNS dot heat map. That is how you make a heat map. How now what I need to pass? I'm passing this data AP over here, as you can see. So this is exactly the same data that I'm passing over here. Okay, and then I'm saying anode is equal to true. What is this anode? Like you can see these numbers present inside these boxes over here. Can you see that? So all these are due to this particular argument. If I make this false, just to show you, see this is how it looks then. There are no numbers displayed, but if you keep it true, the numbers are displayed. What numbers? These numbers in fact. Okay, these numbers are displayed over here. Now you can see what is happening over here is it is simply showing you that for size, depth, total bill with respect to total bill size, like exactly the same matrix has been taken into account with columns and index, and a simple graph has been plotted with respect to colors. Like for example, it sees a number which is smaller will be very dark in color, a number which is very greater will be light in color. Hence, one is very light, then 0.4 you can see it's very dark because this is the lowest number. And just to keep what I was trying to say, that heat map has to do nothing with correlation. It simply displays the data, whatever data you send to it. So that is what I'm doing over here. I'm simply passing total bill, tip, and size column, and just simply trying to plot this. See, even this is also a heat map. Just keep that in mind. So heat map simply takes in data and shows you the output representation of that data in a numerical form. Sorry, in a visual form. Sorry. Okay, so that is what heat map is. So this is what heat map we have got over here. Okay, quite easy in fact. And for writing the same, for getting the same graph using matplotlib, and of course we know that Seaborn uses Matplotlib completely at the backend. But even if you try to do so, the first thing would come is, can we make this kind of heat map using Matplotlib? The answer is yes, you can. Second, will it require much more efforts? The answer is still yes. So it will require much more efforts compared to Seaborn. So in Seaborn it was quite easy, whereas here it is a bit difficult. Okay, okay, here is a bit difficult. Second comes count plot. Okay, count plot. So what does the count plot essentially say? You can say this is a uh, you can say variation of a bar graph, in fact. So what does this count plot help you to do? It helps you to look into the number of unique values uh, and their occurrences present in a column. Okay, just to talk about this a bit more detail. For example, if I go and look into the day value counts, that tells me that okay, Saturday is occurring 87 times, Sunday is occurring 76, Thursday 62, Friday 19. So if I simply say that sns.countplot, inside data you pass tips, directly the data itself, and inside the x you simply pass in the day, and once you do this, you get this as an output. Where heat map is used simply to see the relationship between the numbers. However, this can be directly consumed, but what if just try to think about it is 50 cross 50. So it is very difficult to consume that data. So if you simply do a heat map, the numbers which are very high might be having very different colors. Numbers which are very low will be having very different colors. That is where heat map is used. Okay. So moving ahead, coming back to count plot. So in count plot, as I mentioned, it helps you to look into the number of unique values and their occurrences in a column. So that is what is happening over here. Okay, so that is what it does. It says data is equal to tips and x is equal to day. And once you run this, you see it shows you this Sunday, Saturday, Thursday, Friday. Can we change the order of bars in count plot? You can change the orders of, yes, you can do that, but what you'll have to do is you can change this. See, because essentially what it is taking is it is taking this particular thing as output, but you can change it. It will require a bit of customization by placing in the order value also. Okay, you can do that as well. List of strings, how you want to arrange it. Clear? So, because see, just to mention to everyone, see, please, whenever possible, and if possible, try to explore these various features that are present with respect to every function. Okay. But again, the question comes: should we go to the documentation of C1 library? The answer is no. But again, this depends upon you. In case if your project depends a lot on visualization, or a lot of visualization work has to be done. So in that case, why not? In that case, yes, you'll have to. Okay. Okay, moving ahead. So this is how you make a count plot. Now moving to the box plot. Now what is the use of box plot? Can anyone tell? Use of box plot. So box plot is basically helpful in determining the outliers present in your data. Correct? The outliers present in your data. Okay. So when I simply say SNS.boxplot and I say data is equal to tips, as you can see over here, and then I say X is equal to total bill. So once I run this, so this will make a box plot for me, determining, telling me that okay, these are the outliers present in your data. Like these small dots represent the outliers, if you recall that. Okay. Now the question comes. See, this much easy graphs were easily possible using Matplotlib. But as I mentioned, C1 can make much more good graphs. How? Let's look into that now. Please look carefully, first of all, everyone. Okay. And just give me a second. Let me simply place this variable at the last. Okay. So first of all, how to make this graph? What we are doing in this? So we are saying SNS.boxplot. Okay. Data is equal to tips, that use the tips data. Then you're saying X is equal to day, that use the day variable, in fact. Okay. That use the day variable. On y-axis, we use the total bill variable. Now, what is this? What is the meaning of this? It is saying that I want to look into the outliers in the total bill column, but not individually for total bill. Like instead, what I do not want to do is I do not want to look for the total bill outliers at a single, like for the whole data. Instead, what I want to do, I want to look at the outliers of the total bill column with respect to day. Okay, so that is what you're doing. So total bill column outliers, but with respect to day, with respect to Sunday, Saturday, Thursday, Friday. That is what you're doing. So you're saying on X axis, I want the day. On Y axis, I want the total bill. And then hue is equal to day. Hue again helps you to have different colors. And then palette is equal to pastel. What is this pastel? This allows you to have different kind of combinations of color. For example, if I say rainbow, there are certain predefined palettes that are there. For example, rainbow, if you see, the colors changed a bit. Okay. Then there is magma. In this, dark colors are used by default. So if you see, dark colors have been used. Then there is Virdis. So if you see VIRI also, I think I made a spelling mistake. So yes, can you see how the colors are changing with respect to palette? So it's up to you which palette you would want to use. Okay. So for pastel, it shows you the light colors. Clear to everyone? Also, just to mention, as I mentioned, that X and hue column are very, like X and hue parameters are very same. They are very same, but the hue parameter is important. So if you say that if they are very same, can I remove one? Yes, you can remove the X one completely, and it will still work. For example, if I do that, so this still works. The only difference is that instead of having labels on X-axis now, you are having them in the legend. Okay, so that is the only difference that usually happens if you're removing the x-axis. But the graph is still the same for all the 4Ds, but now on x-axis, nothing is displayed. So you can keep that in mind. And if you simply do this, then it is much more easily visible in fact. But yes, x is not a mandatory parameter over here. And same way, SNS.boxplot, data tips, palette rainbow. As I mentioned, there are various palettes present in the, and if I try to see, let's see if we have For example, this is argument that I have referring to, and I hope they might have given a list, but they have not given a list. Okay, but yes, you can go to the matplotlib documentation also. Okay, and it will give you the whole uh, list of pellets, in fact. Okay, that represent. And then I'm saying orient is equal to h means I want horizontal box plots. That is what you are saying. Okay. So now if you see what is happening over here, here I said data tips, x-axis day and y total bill. Okay. But here I'm simply not specifying any x, any y. What I'm doing is data is equal to tips, palette rainbow, orient edge. Now by default for all the numerical columns, do you see it makes a box plot. For all the numerical columns, by default a box plot is plotted. That is what happens. Same way again, x-axis gender, y total bill, palette pastel, hue gender. So exactly the same thing that was present above. And if I take this one above, this one will be helpful in fact, just to create an order. Okay. So for gender also it's possible. Now there is an amazing thing what you can also do. Can you do it for at much more granular level as well? For example, you told that for total will at a day level I'm able to see. Can I add one more dimension also to this? The answer is yes. How? Now this is where things will get interesting. So instead of keeping hue and x variable exactly same, you say x is equal to gender, y is equal to total bill. Means on a x-axis it will be female and male, and on y it will be total bill. Then you are saying hue is equal to day. That with respect to these two variables, now I want to have the day information as well. So what does this say? That when the person is female and it is Sunday, Saturday, like for all the days, you are able to see the outliers now. Do you see this? So with respect to genders, for all the days in total will you are able to see the outliers. So just essentially three dimensions in a single go. Now my question to you is, what do you think? Are the graphs good looking compared to Matplotlib? These circle means outliers. Okay, we discussed this in fact in detail when we are going over box plot in Matplotlib. So these are the outliers. Okay. So the graphs are far more better looking in fact. With just again with few lines of code, no X label, Y label, nothing is required. In fact, you simply pass in the data, all the X label, Y label, all those things are taken care by itself. Okay, and graphs are far more better looking than Matplotlib. Now comes the violent plots, which you have already seen, but I've simply placed in one more image also of violent plots over here, how you can kind of interpret it. So if you remember, violent plots are also helped in using or seeing what? Two things, distribution as well as what? Outliers. So it helps you to see those things. So it is telling you like wherever this and it is the upper adjacent value outside points, and it will also have this distribution like the box inside the violent plot. Just to show what I'm referring to, I'm referring to this. Okay, we will see that. Don't worry. And these are the lower values. So we already have talked about violent plot in depth. Just moving ahead. So see, using matplotlib, this is how your violent plot looked. So PLT is the matplotlib. Okay, using matplotlib, this is how your violent plot looked. But now if I run the same command using C1, so simply sns.violent plot tips total bill. That's it. Okay, that is what I'm doing. See here, no label, XX label, Y label, nothing is there. Here, when I'm doing this, it is far more clean. You're having a label, and even the graph is also far more beautiful to look at with the information. Correct? So it says that sns.violent plot total bill. So more proper distribution is also in fact visible compared to this. Which graph do you prefer, matplotlib or the C1 one? So just one line for both of them, but you can see the graph is far more better for Seaborn. Now, same way you can do multiple customizations as well with respect to violin plots also, like we were doing for box plot. So you can say on x-axis day, y total bill. And again, another palette is cool warm that I'm using. U is equal to day. And once I'm doing this, you can see you're having four violins for Sunday, for Saturday, Thursday, Friday separately. And seeing that, okay, now the total bill variation or distribution, in fact, and also the outliers with respect to days. So multiple graphs in a single go. And how we did over here, if you remember, for gender, multiple days of total bill, same can be done on violin plot as well. How? X day, Y total bill, hue gender, palette, rainbow. You can also use pastel, whatever you want to use. Okay. I put in a list by mistake. So this is how it looks. Okay. Now for Saturday, Sunday, Thursday, Friday, we are having for all the days the distribution as well as their violin plots. So much more good to look at, in fact. Okay. But yes, and you see you have these lines in between indicating where does the median stand into. Okay, so quite good looking graphs by a single line. Now your question would be, can I combine these? The answer is yes. See, that is how you can do that. Single violin, but again indicating two information. So you're saying X day, Y total bill, U gender, palette cool warm, but split is equal to true. So now a single violin is only used, but for male, female, separate information is there. Because essentially, see, this information is simply a duplicate at both ends, correct? So why not? If I can have the information in a single violin only with respect to the gender for every day for total bill. So that's really a good thing you can achieve, in fact. Okay, so it shows that on Saturday, usually the median values are very, very similar of male and females, in fact. There's a deviation on Thursday. On Friday also, they're kind of similar, but there is a huge deviation on Sunday also in medians. Do you see this, everyone? So beautiful graphs, just with single line, and far more customizable and informative, in fact. That is what is the capability of C1 library. Okay. Moving ahead to bubble plot. So you already know bubble plot. So how to make a bubble plot? Again, it is simply the scatter plot only, but again, an extension of it. So simply say sns.scatter plot, data tips, x tip, y total bill, and instead in the size column, like in the size value, we are specifying the size column. Okay, do not get confused with why it's both size. So one is a column and one is the argument. And then I'm saying hue is equal to gender, alpha you're aware about, legend is equal to true, that I want to have a legend. And you can also determine the sizes of the balls, like how thick or how big or small the sizes should be. So once you make this graph, see how beautiful this comes out to be. So with respect to gender, so blue balls are indicating when it is female, orange when it is male, and the size of the bubble, or you can say marker, is representing the number of people present at the table. So this big size indicates 6, small dot simply indicates group of 1. Okay. So that is what it is indicating, and this is for size column. So, but just by again a single line graph is much more good to look at. So the white lines in between of one plot indicate the median. Toby, those indicates the box, in fact, directly. So this is exactly similar how the box in a box plot is. Okay, that is what this shows you over here. Right? Because, and if you remember, we talked about this, that the line present in the box indicates the median. So here also that similar line is indicating what? Median. Okay. Okay. Now comes the last graph, the pair plot. Okay, now C1 also allows you to have one more good thing, that is a pair plot. Now, first of all, you do not run a pair plot when your data is very, very huge. Let's say if you're having millions of rows, you do not run a pair plot. You only run pair plot on a sample or small data. So a sample around, let's say, 10,000 or 5,000 rows, and it's more than enough, in fact. That is when you run a pair plot. Now, what is a pair plot? So as soon as I say sns.pair plot and pass in tips, and when I run this, so it takes a few seconds and then plots something. What? It plots all the columns with respect to all the columns, and all these these are numeric columns, like total bill column with respect to all the columns. So total bill with respect to total bill, total bill with respect to tip, with respect to size. So that is what it is plotting. So when the column is similar on x-axis and y-axis, you can see it's plotting a histogram for you to have a look at the distribution. And with other, it is simply plotting a scatter plot. Do you see this? So this is plotting, like if you want to simply see the relationships, all the graphs with respect to all the graphs, this is how you do it in fact. Okay, but do remember, if your data is very, very big, you do not run this. Why? Because it will take a lot of time to execute in that case. So you only do it for the small sample or small data. In our case, the data is small, that's why you're simply able to use it. Now, another thing that you can do with pair plot is you can also pass in variables like hue. So I'm saying sns.pairplot, pass in the data tips, and then what you're doing, you're saying hue is equal to smoker. Now your data is plotted, but with separate colors indicating that what belongs to when the person is smoker and what belongs to when the person is not a smoker. So if a person is smoker, orange dots. If a person is not a smoker, uh, then it is using blue dots. So now for total bill column, it is showing you how the distribution is. So if the person is not a smoker, usually tend to spend more, okay, and is more centric compared to when the person is a smoker. Okay, and that is information across all the cases, but except size. So you can see that okay, there is no different in the group of size when the person is smoker or not, usually. But yes, still more number of just a slight deviation when the person is not a smoker, the group size is sometimes higher. Do you see this? Like the occurrence, or you can say density, is comparatively low. That is how you can say. Group size, however, is indicating this, but when I'm saying this, so smaller groups are comparatively higher when the person is not a smoker. And also here also, in fact, because if you see over here, when the person is smoker, usually there are no big groups, but when the person is not a smoker, there are certain very, you can say, indications of that there are groups. Okay. So again, multiple ways to look at a graph. So this is what I wanted to talk about Seaborn library. This gives you a good enough information of what Seaborn is capable of, what Seaborn can do. Okay. So let me do one thing. Let me share this graph code with all of you. Please go through this. Try to make line charts as well by yourself. Try to make line charts and then try to also make histograms using Seaborn and get familiar with this code. And once you're done, do let me know so that we can move ahead with other things. So let me share this code. Just give me a second. Please give a thumbs up to the file if you're able to download them and have a look at them. Okay, good. So please go through these. Try to make some new graphs by yourself. In fact, that might help your understanding to be good in terms of Seaborn. You can go to Seaborn website and look for various graphs and try to implement the same graphs with this data. Okay. So once you are done with that, do let me know. Then we can move ahead. And also when you're going through this whole code and you are okay with it, then we can move ahead. Okay. Thank you. What is the error it is giving you, Jaya? And you need to share with the traceback. Traceback is not the error. Jaya, you need to. Uh, yes, you can. Please do. Let me unmute you as well. You can mute yourself and share the screen.
Can you see my screen?
Yes, I can.
Yeah, I have executed this and this, it all went correct. But when I come to here, this is correct. Only here I'm getting that error.
So
I
if
didn't
you
make
go
it.
down, error is usually displayed at the end.
Sorry?
If you can go down, error is usually displayed at the end.
Oh, I see, okay. Box plot cotton, next.
Can you go
Table
above?
document cap.
It's not gap. It is elf. Just give me a second. I think. Put. Just give me a second, please. Because
You mean here is a L?
so it's due to a different version of C1 that you are using. That is the reason. But yes, you can simply remove this last argument. Remove this because it could be that your version of C1 is new. But yes, now you run it. That's why it is not able to identify the gap.
Okay, okay, thank you.
Okay. So you can mute yourself as well. In fact. Yes, Toby, please. When to use when? We already talked about when to use box plot, one plot, histograms, bar plots. We talked about all those things, Lakshmi. But if you, example, if you want to see outliers, you see use box plot. You want to see distribution, histograms, occurrences. You want to see relationships, scatter plot. So you already talked about those things. Yes. Yes, Toby, you can unmute yourself as well, please. Okay, let me. Okay, wait, just give me a second. Let me raise a command from there. You can simply click on yes.
Okay, yeah. Can you hear me now?
Mm. Yes, I can.
Okay, so this is what I'm trying to do. So I'm trying to use the example from this documentation. So I'm doing something like this. So while doing that, I got this error. So I'm suspecting that there is no data, just like you used here.
No, no, no. Go down, go down. We
Okay,
cannot. We'll have to first of all look into the error. Scroll to the error at the bottom of the error. Always inspect the error. What error is telling you? Go to the down of error. Scroll.
that's here, right?
No, no. Scroll. It's the. If you see on right, yes,
Okay,
it can be
okay,
scroll.
okay, okay,
Go to the bottom.
okay.
So it says go above, go above. Could not. A
That's
bit
it.
above. No, no. A bit above. Okay, wait. Could not interpret value tips for X.
So,
Okay. So what it is saying you that it is not able to understand tips.
mm-hmm.
Do one thing. Okay, I got it. What you're trying to do.
Mm.
Remove. Can you show the line numbers? Click on view and show line numbers.
Okay, show line numbers. Where is okay coming?
Here only in the view menu only. Go down. Here it is. Above, above, above. Show line numbers. Toby.
I'm coming. Wait. Okay, got it.
Okay, so remove line number 3.
Line number 3. Okay,
Remove it.
okay.
Go to line number 7. Right.
Line
Data is
numbers.
equal to tips.
Mm-hmm. Okay, so here will be data.
Data is equal to tips. Remove diamonds.
Data is equals to
Tips
tips.
without quotes because it is representing our data variable
Okay, okay, okay,
with the data that we imported.
okay. So this should work now.
And remove in hue. What you can do is you can in hue you can write in line number 8 in hue instead of cut write uh, uh, smoker. Let's use smoker in line number 8.
Line number 8. Okay,
You write smoker
it's okay.
in hue.
Okay, in hue. Okay, okay, okay. Smoker.
So what was the issue? Let me tell you. What you were doing is you were using diamonds data set, but
Mm-hmm.
because you're not aware about what all variables are present, hence it was giving you error. There was
Error.
no tips column in the diamond data frame. And now in line
Mm-hmm.
number 8, only in X, instead of tips, write total bill, total underscore bill, the column that we have. Or you can simply write tip. Line number 8 only, X is equal to tip, not tips. Remove the last S.
Okay, X is equals to tip. Okay,
Run
okay,
this.
okay. Let me run
You need to
this.
also remove line number 16 because the tips info, line number 16 and 15, remove both.
Okay, line number 16 and 15. Okay,
Run it now.
let's see. Oh, amazing. I see. So, but because what I was thinking is, since we had the diamond, so the diamond is more like I would say, since it's a variable, so I'm using the load data set to load the data, which is tips, which is probably maybe I need to put the extension. So I was thinking it
What
will
you are
work.
doing is, let me tell you, you are loading the tips data set, but you are using the variable names which were from the diamond data
From
set.
diamond data. Okay. I see.
Yes.
I
Okay, so that's why you are getting the issue.
I see. I got it. Thank you very much. Got it.
Yeah. Okay. Good. Okay, the question I asked by Abhay is, what is the best way to use Python in insurance? So we best way to use Python. What do you mean by that? Your question would be, how do I use data science in insurance domain? If that could be the question. So again, in insurance, what all things, for example, uh, based on images of like in terms of vehicle insurance, car which has met an accident, based on that you can simply make a image model that can understand how much damage has been done for the initial uh, costing or initial estimate of the amount that the insurance company will have to pay. Second, what you can also do is whenever initially a person gets insurance, again, an image model, when a person simply clicks the photo and it is able to detect all the defects or scratches present in the car. You can also make insurance a model in insurance domain itself, which can make variable pricing with respect to different components a person is choosing. So just think about what all things can be easily done, or what all things require a lot of efforts. That is where you can bring in data science predictions, whether this person will be taking insurance or not. You have multiple informations. What price would be the best price for this particular person to get converted? So multiple things can be done. For claim verification or documents verification is also when you can use data science fraud detection model, in fact, to detect if there is something off with the documents and those things. Data is not similar, labels are similar to be. So total bill with respect to total bill, total bill with respect to tip. So all those informations are plotted. Okay, some of the graphs would repeat. For example, tip and total bill and tip are the same graphs, just the orientation will change. You can either you need to reinstall or restart your kernel first. If you still get the error, you need to install see the version of NumPy and those things. I'm not sure why you're getting this error. You should ideally not get this error. Are you using a virtual environment, Yugender? Usually, no one gets these errors, but this comes due to the different versions of the packages. So you're having a version of uh, and what ID are you using? Just curious on that part. I hope you're using Jupyter Notebook only, correct? Try to run this on simply on labs. If it still gives you error, you should not get this error, however, but I'm again not sure why it is giving you this error. It's basically with the versions that it says that okay, it should use NumPy 1, but you have NumPy 2 something. So that is error it is indicating, but you do not get even errors of modules. In fact, I'm not sure why you are getting this error. But again, try to execute this on Simply Labs and see if it works fine for you. Protik, that could be due to the pandas again version. So you can remove the numeric only argument. Initially, the numeric only argument was not there in the earlier versions, but now it has been made mandatory. Due to that, it might be giving that error. So you can remove that numeric only. If it works fine without that, then that's totally good. You need to put some data, Jaya, then only it will work. So you need to put some data into X. So you have simply copied the code, but you need to put in some values also, correct? Like what column you want to use in place of X, what data you are going to use. So all those informations are missing, hence you are getting the error. So say data is equal to tips, X is equal to, let's say, total bill, like that. So has everyone gone through the code? Any questions, any doubts which are left unanswered? Please let me know. If you have gone through the code, please write done. Or you're still going through it. If still going through, please write reviewing. Lakshmi answered that question. Basically, every graph, when we talked about it, for example, line chart is used for looking trend, scatter plot is used for looking relationship, bar plots are used for comparing categories, pie charts are used for looking the parts of whole ratio, parts to whole ratio, histograms are looked for the distribution or occurrences, box plots are used for looking into the outliers, Vernon plots are used for looking into the outliers and the distribution. So we talked about each and everything. So that question is already answered, in fact, and I answered it just when you asked it before as well, in fact. So every graph has various requirements that it depicts, in fact. So it tells you where to use what then. Okay, so I hope everyone has completed the code go through, and so let's move ahead now. And I'll talk about one, two more libraries which are amazing and good to use library, in fact. So is my screen visible to everyone? Okay. See, so far we have gone through Matplotlib and Seaborn library. Now those libraries are used for making static graphs. Means if you are doing static graphing or graphs which do not have live data input, those are good to go. Okay. Means once a graph is plotted, it cannot be changed. But what if you want to make a graph dynamic? When I say dynamic, that you can change the graph, you can zoom in, zoom out, move the graph, change what is present on x-axis, what is present on y-axis, or make a complete dashboard. So like how it is done using Power BI, Tableau, and other tools. Okay. Can we do that in Python and using any library? The answer is yes. So one of the library that allows you to do that is Bouquet. Okay. One of the library that allows you to do that is Bouquet. Bouquet allows you to have dashboards, allows you to change x-axis, y-axis, and all those things. We'll be not going through this library code. I'm just introducing you to this library through the website. Again, it's totally up to you in case if you want to learn this. But again, this is simply not mandatory or required, but totally depends upon you. In case if you want to learn this, you can do that. But again, just to show you what this library is capable of, if we go down, see all these are various use cases or showcases of how this library can help you make different graphs. Okay, first of all, this is just to show you. If I click on, let's say, dashboards, uh, let's go to demos directly. You'll be able to I'll be able to show you what I'm talking about. For example, let's say this is the data. If you click on it, so this histogram or this kind of graph is completely made using what? Made using Bouquet library. Okay, please give me a second. So this is made using bouquet library. Now, if you see, first of all, how you can have a graph over here. This is again indicating this graph only. Now you can see, first of all, this helps you to move this graph. You see, this is not possible with what? Not possible with matplotlib or bouquet. You can also zoom in. For example, if I simply do a lasso selection to see how what I can do. Any data shape that you would want to select. So this is the data that I've selected. Now see, with respect to this data, only the histograms are plotted over here. You see this, only that data points are selected. And same way, this same distribution is shown over here as well. So this is how you can see a dynamic graph looks like. You can reset it completely as well. Okay. You can do box select also, like you want to select only this data. Okay, only this data. So all those things can be directly done. With respect to only this data, you want to look at the distribution. So everything can be done. You can zoom in as well if you see. You see how graph over here is changing and how it is changing over here. So zooming in, zooming out. Okay, so all those things are possible by simply selecting these options. So this is one of the demo, one of the plot, just to show you others. For example, let's go on this, how you can dynamically change x-axis, y-axis as well. So this is data based around movies and their informations. So it's saying that like it is having certain information on movies, and you can of course go to this movie explorer data, what this data information is. But what it is saying is that you want to select the movies which are having reviews, or let's say 100 or 110, or very high number of reviews. See, you can only see, it shows you how many movies are selected, 6. And if I'm saying that minimum number of reviews should be at least 10, or let's say 10. So it says 11k approximately movies are there. So you're saying that okay, it should have approximately have done 100 million in box office. Let's say 102. Okay, genre, if you want to select genre. So what I'm trying to show you is, with respect to how you're moving these things, you see how more data is getting populated. Do you see that? If you keep on moving this, so it's only selecting data with respect to that. Year released, which year you are looking into. Okay. So see how data is changing with respect to that. So start from 1950 all the way till 2014. Okay. If you select less, so of course less movies are shown over here now. Minimum number of Oscar wins, let's say at least 2 Oscar wins. Let's select maximum number of movies. So this shows you all the movies that have won at least 2 Oscars. Around the World in 80 Days, Dracula. And you see, when I'm taking my this crosshair on any particular thing, it is also showing me this particular box indicating the information, title, along with year, along with the budget. Do you see this? Okay, and you can also change what is should go on an x-axis, number of reviews or length. Let's say on x-axis goes the length of the movie. On y-axis, let's say goes the uh, number of reviews only, let's say that way. So it tells you that okay, uh, movies with greater length receiving Oscar chances are less. Like if I try to interpret this graph, but usually most of the movies that have won 2 Oscars are between 100 to 140 minutes. That is what it indicates. Okay, and you can of course go read anything and it shows you the whole information. You can even put in director name contains what, cast name contains what. So all these things can be used. Okay, so that is what I'm trying to show, that this is again a visualization library like Matplotlib and Bouquet, but far more customizable, allows you to do a lot more different things compared to what Matplotlib and Seaborn allows you to do. So amazing library. And if I try to open this up again, this is how it looks. You can see how with respect to years, how this whole thing is changing. You see, children per woman, total fertility, life expectancy, and let's click over here and simply do on the play. So this even plays it as a video. Do you see this? So what's your thoughts about this library, everyone? It's a great library, and multiple things. You can even make 3D graphs using this, just to show you. For example, this is a graph. You can of course move up and down, and you can see in any direction. You can zoom in as well, in fact. Okay, so comparatively, far more better library than Matplotlib and C1, and of course, it is having its own set of codes and those things. So, up to you in case if you want to learn those things. So, let me share first of all the link of this library. Also, for example, let's say you want to do something. Let's say you want to look into some of the graphs and those things. You can simply go to the documentation and see how to make all these graphs and everything. The whole documentation will tell you. For example, let's say you want to make, let's say this kind of graph, histogram. Simply click on histogram, and it will show you how to make those graphs. Okay, simply let's say this will indicate colors. However, sorry, but yes, you can go around the documentation and see topic guides, whatever you want to use and how you would want to do that. So the whole documentation, it's also open source, just to mention, it's completely free to use. It does not charge you anything, in fact, for using this library. Please give me a few seconds, everyone. Okay, so you can explore this library in case if you would want to. Okay, it's not a mandatory piece, honestly, but again, totally depends upon what's your use cases, and in case if your use cases are around making good graphs, so then for sure this library will come in handy for you. Okay, any questions, anyone? So I've shared the link with everyone, in fact. Okay, any questions, anyone? Okay, can you show an example of dynamic data variation? Dynamic data variation means? Okay, I think you're referring to a demo, correct? So that is what we did. No, I just, okay, let me show you. Just give me a second. So if you go to demos, and for example, this one only, in fact, it allows you to change x-axis, y-axis directly. So that is what I was talking about. Like if you can choose whatever x-axis you would want to, you can choose whatever y-axis you would want to have. Okay, so it allows you to change x-axis, y-axis, all those things directly. So it's a graph variation. Data at the back end is same. Data is not changing. It's only what we are selecting. In fact, on x-axis, y-axis, you can also filter the data over here, for example, in the graph. Okay, so that is what is happening. Does it make sense, Altaf? I hope you look. If you have our data. Okay, I think then you're referring to how can we make this graph? That is what you're referring to, correct? Like what do we I write a code for it? Okay, so that is what I was referring to. That will not be going into the coding part of Bouquet library because it's a bit different. And if you do that, because it will take time, it has components which I'll have to explain first, and it takes its own set of time. So Bouquet is not a part of our course as well, honestly. And again, there is and now because you've already gone through two to three libraries, if you simply start going through the documentation, it is far more easy, in fact, for you to now learn because you already know what how the graphs are, what histogram and those things are. But yes, we'll not be looking into the coding part of it because I cannot simply show a code and say you that okay, use this code, it will work for everything. I'll have to explain each and every component of it, and then it essentially goes into explaining the whole library itself. I hope you're understanding, correct? So yes, so stopping the share, let's uh, open pool and then let's go for the break, and post the break we'll continue and talk about other things, and then we'll start talking about probability distributions and those things. So launching the pool. Okay, I hope everyone has pooled, ending the pool. So let me share the screen with the timer. Let's go for a break, and after the break, we'll continue to talk about other concepts. Just give me a second, please. So I hope my screen is visible to everyone. Okay, so let's go for a break, everyone. See you after the break. Thank you. So is everyone back? Okay. So let's move ahead and let me share the screen and talk about one more library. I hope my screen is visible to everyone. So this is another library. Just again, want to talk about this plotly. Now, part of some certain part of this are paid, like you'll have to pay money to get the access to certain components of it. But yes, parts are also free. Again, this is far more advanced library. Like it helps you to make dashboards or applications which are very similar to the enterprise versions of your dashboarding tools. In fact. Okay, so it supports generative AI and these kind of stuff as well. Just to show you, for example, if we get some, let's say, Michelin Guide to France. So again, it also helps you to select data and all those things. Okay, selecting a particular area, select a particular department. Okay, and then you can select filter by the ratings and those things. So it allows you to zoom in and zoom out. See how. So what I'm trying to show you is that there are a lot of uh, best applications or best libraries, for example bouquet being one, this being the second, that allows you to make far more advanced dashboards and graphs. So cleanly everything is possible in Python in terms of visualization as well. Okay, like this is showing you how image essentially looks at and all those things, and it is moving in frames and all those things in fact. Okay, so that is what this live, and see it's allowing, this is again a app. Just try to think about it. This is simply a app. Okay, it's not a website. This has been made on top of a data in fact. Okay, same way like looking at a x-ray analysis, another uh, dashboard medium using this particular library, axial view, sagittal view. Okay, so if you zoom in like it shows you how the whole thing is moving. Okay, this is with respect to the 3D data, of course. Okay, so really certain good graphing, it allows you to have a look at. Okay, so if you look over here, so the intent of me showing you these things is that in case if you ever want to look into is something there around this, so most of the cases it would be there are a lot of libraries in Python in fact. Okay, so a lot of stuff can be easily done in Python nowadays, from making uh, games to websites to backends to front ends to in fact. So all those things are exactly possible. Like you can see how you can select it and all, you can specify threshold and all those things. So yes, quite and again this is the data set. Just if you see, this is the data set they've shown over here. This is the data set. You can add a filter, reset the filter, true value versus predicted value. And you see this, so this is a Titanic binary classification. As of now, you are not aware about what classification and those things are, but this is the machine learning model that they are showing you the results for. Okay, and how this whole value and everything is moving. So again, far more better graphs, far more good graphs, in fact, better visualization. So let me also share the link of this library as well to all of you. You can explore this as well. And there are same way many more libraries. I'll not say only these two are the ones, Bouquet and Plotly, but there are many more libraries that are present in the Python space. But yes, up to you, whichever you would like, whichever you would want to use, you'll have to explore. No one comes and gives you the name. It could be that okay, they are famous, they have been present in various vlogs. Someone you'll have to explore. You might have to watch videos, some might recommend you in videos, but essentially these have to be researched. They tend to do certain marketing if they are having some price plans. But usually for free libraries, you come to know about using by your own research and those things. Okay. So any question? Okay, so I hope there are no questions. So then let's move ahead now. I hope everyone is clear till this point. Okay. Okay, then let's move ahead. So let me stop the share. Now we'll talk about probability distributions and certain statistical things, in fact. So just to give you a recap of what we have done so far in terms of since the course has started, so that you can kind of have idea about what we have done. So we started talking about what before this we started talking about the Python and the data science space. In the previous course we have learned how to program Python, how to write codes in Python library, in Python programming language, and what are various loops, conditional statements. We looked into all those things, correct? And then post that is when this course started. So in the first course we learned about the Python programming and what are programming languages, how to install, and all those stuff, in fact. Then is when this course started, after that particular course. And in this course we started looking into what is the concept of libraries in Python, what is NumPy, Pandas, Matplotlib, Seaborn, and around them what are the various concepts, why do we tend to use Pandas. We also looked at the life cycle of a data science project, where what is used and why we are learning these libraries, how do they make sense, how are they connected. So we looked into all these things as well, in fact. Okay, and that is where we are currently. So we have covered NumPy, Pandas, Matplotlib, Seaborn. Okay, essentially four libraries, from doing numerical calculations to handling data to making visualizations. Now what we'll be doing is we'll be talking about certain statistical part in terms of data science, like what are distributions, probability distributions, how do they work, and all those concepts, in fact. So that is what we'll be doing now. But yes, before moving ahead, I hope everyone is clear. No one is having any questions, no doubts. But if you have any, please put in the chat. Any questions, anyone? Okay, then I take that as a Yes, that there are no questions and everyone is clear so far. Okay, so that is good then. Please give me a few seconds. So let me share the blackboard now and we'll start to discuss further things. In fact, okay. Please give me a few seconds. So I hope my blackboard is visible to everyone. Please give me a second. There seems to be an issue with the system. Please give me a second, everyone. Okay, I'm back. Got the co-host rights. Sharing a screen. Do let me know once my screen comes up. I hope my screen is visible to everyone. Perfect. Thank you everyone for being on the hold. Okay, so what we'll be doing now is we'll be talking about probability distributions, in fact, and all the concepts around them. So let's start with them, in fact. Let me zoom in to 100%. Okay. So probability. And I'll talk about why we are learning probability and the whole story around it. Don't worry on that part. Sorry, my spelling is wrong. Okay, probability. Now, just to first of all talk about why we are going to learn probability is, see, all the machine learning models, okay, what do they take in? They take in data, okay. What do they give us output? They give us output sometimes, values, okay. For example, that what is going to happen, whether it will be raining or not, whether what will be the sales in next 6 months. So these kind of values, okay. But at the back end, there is a heavy use of probability by the models. Okay, there is a heavy use of the probability by the models. So these models tend to give probabilistic output. Okay, that whenever it is returning your output, it says that okay, the probability of this happening is this much. Okay, it's not always 100% correct, but they tend to give you values in return as probability. Okay, so all the deep learning models, classification models specifically, I'm referring to, are having a concept of probabilistic output. Okay, the probability of this happening, the probability of that happening, and that is how the outputs are generated in fact. Okay, and that is why we are learning probability in our today's class and in the subsequent classes. All the probability distributions. We'll talk about this thing a bit more when we'll be diving deep into the distributions and those concepts, where you might start thinking, okay, why is the need of learning probability distributions? Because many of the algorithms tend to work only on data which are following a particular probability distribution, and that is the case where we talk about having different uses or different things on the probability distribution, like why we are having so many probability distributions, why we are learning uniform, normal, binomial, Bernoulli, these kind of distributions, because as I mentioned, algorithms tend to have those concepts at their backend part. Hence, we are learning these things. So we'll start with the probability. I hope everyone knows about it, but still I'll just give you a recap around it. So basically, it is So probability is a mathematical term for determining the likelihood of an event happening. Correct? That is what is probability. Now, we'll be further talking on this in fact. So examples, let's say you're tossing a coin, or in toss of a coin, there can be two outcomes, correct? And I'm taking this example because everyone can relate with this. let's say head and tail. Now what I'm talking about over here is that it says probability is a mathematical term for determining the likelihood of an event happening. Now your question could be, what is an event? So event is what is you determine. For example, for me, getting in head is an event. I'm getting head is an event for me, or getting a tail is an event for me. It determines basically what you want as output. So I'm saying that this is an event for me. Let's say this is an event for me. So what happens is you can simply say probability of getting a head or event for me is number of times the event occurs divided by total number of possible outcomes. So hence 1 by 2. Why 1 by 2? Because what are the possible number of outcomes? Our head and tail, correct? Two possible outcomes. How many times our event or head we can get? Only one time if you are tossing a coin to one time. So the possible outcomes are head and tail, and head can only appear, either head can appear or tail can appear. Hence only one time. Hence the probability comes out to be 0.5. Everyone knows about it, but still. And the probability, what is the range of probability? Can anyone tell? What is the range of probability? The value is between 0 to 1. Correct. Yes, you are correct. Okay. So that is the range of the probability. Now, if I talk about applications of probability, it is kind of used everywhere. For example, in weather forecasting, in weather, all the forecasting models for temperature, rain, humidity, whether it will be a cloudy day or what it will be. So all these models that you can think about give you output of probabilistic value. So it gives you a probability that, okay, the probability of the weather being tomorrow in range of 35 to 40 is this, or the probability of raining is this. You might have heard about it, correct? That this is the probability of this happening, this is the probability of this happening. Correct, everyone? So that is where this concept of probability essentially comes in. Whether same goes for healthcare. Like if I try to write about various other domains, healthcare, so predicting a disease or illness, a disease or illness, or whatever you want to call it, or cancer. I'm simply trying to write certain names also. Tuberculosis, XYZ things. All these are probabilistic outcomes. Based on these symptoms, the probability of the person having this particular disease is this much. Same goes for sports also. If someone tends to watch sports, there is a meter at the bottom, correct? The probability, or you can say chances of winning by team A is 60%, chances of team B winning is 20%, like this. You might have looked into these things for sure. So in sports to banking, the chances of the person paying back the loan is quite high. Of course, what kind of data we tend to use? We tend to use kind of data like the person's civil score, or past EMIs, current number of loans, salary, and XYZ informations. Correct? That is what we tend to use to determine if the person might pay or not. Okay, so of course all those information might go, but probability is used and it goes till all the domains approximately. You can use the concepts of probability everywhere. Okay, so that is the first thing we are talking about. So hence, as I mentioned, that we'll be talking about the part of probability and how it is used and all the things around it, in fact. Now, let's start with the probability distributions. Let's start with, so how many of you know what are probability distributions? You might have learned about this during your uh, colleges or your schools. But yes, how many of you know about probability distributions? Any idea on what is this? Okay, next is, so just to mention, probability distributions for probability distribution, I'll simply write this as PD. Let me write the short form so that you do not get confused what I'm trying to say. Is a function or formula that gives, and I'll try to explain in easy words. Don't worry if the concept looks very heavy to you. Don't worry, we'll look into this very easy terms. This in very easy terms. Gives you the probabilities of all the possible outcomes of an experiment. Okay, now your question might be that what is this experiment and what have you written? So as of now, think probability distribution as a formula. Just for your own sake, think of this as a formula, okay, which I've written over here as well. That probability distribution is simply a function or a formula. What does it do? It gives you the probabilities. It will give you the probabilities of what, of all the outcomes, possible outcomes, of all the possible outcomes from an experiment. So probability distribution is a formula that will give you probability of all the outcomes in an experiment. Now the question might come that, okay, what is an experiment? Okay. An experiment is, for example, anything that you're doing, you call it an experiment. For example, rolling a dice, tossing a coin, pulling a card from the deck, pulling a ball from the bag. Like all the classical examples that you have studied, all these are experiments. Okay. Okay. So that is, first of all, what is a experiment? And just to specifically talk about one more thing, it's simply a process. You can say it's a process, but with more than one outcome, with more than one possible outcome. That is a requirement. Okay. Clear everyone so far? Or if I try to rephrase this and write it in a different manner, so I can say that a probability distribution describes how probabilities are distributed across all the different possible outcomes of a process. I simply rephrased it, but again, if this helps you in understanding that what I'm trying to say over here is describes how probabilities are distributed across all the possible outcomes of a process. For example, if you're tossing a coin 3 times, what are various outcomes and what are the probabilities around it? What is the probability of getting 3 heads? What is the probability of getting 2 tails? What is the probability of getting 1 head? What is the probability of getting 2 heads? So what if I tell you that, okay, if you have a formula that can directly give you all these probabilities. So that is what you can say a probability distribution. Means how the outcomes are distributed. Okay, so that is what probability is. How the distribution of probability or how the distribution is of or of the outcomes are there in your experiment. What is the how is the probability distributed? For example, and we'll talk about this in continuous terms. In which area is the most probable area if you simply pick up a random value? How is the probability distribution distributed across your experiment? That is what this probability distribution refers to. And of course, it changes with respect to data. If your data follows a different thing, probability distribution might be a bit different with respect to your data. So far clear, everyone? Any questions? Okay, perfect. Now, probability distributions are divided into two types essentially. Okay, probability distributions are divided into two types. So if I try to just give me a second. So I'll simply write PD to talk about that probability. So when I say PD, it refers to probability distribution. You're correct, Prajita. The one is discrete probability distributions. Another one is continuous probability distributions. Now my question comes to you. Can you tell where you have heard these terms discrete and continuous? Anyone able to recall it? So if you remember when we talked about the types of data, do you remember continuous data, discrete data, qualitative, quantitative. That is where we have studied it. Did we discuss the data types? How the data is divided on its types? Did we talk about that? Correct. So that is where these terms are coming from. So discrete probability distributions are when the data is discrete. So these are for discrete data type. And these are for continuous data type. Okay. Certain examples of what are various discrete probability distributions. Just if I write those down. Example, Bernoulli probability distribution, binomial probability distribution, Poisson probability distribution, hypergeometric, and there are many more. Again, it keeps on going and on going and going. Okay. Please give me a second, everyone. And for continuous, examples are normal probability distribution. Okay. Standard normal, uniform distribution, uniform probability distribution, exponential, bimodal, comb, edge, and this list will keep on going and going and going because there are so many types of probability distributions that can occur in fact. Okay, so it keeps on going and going. But for our case, what we'll be studying is we'll be studying about uh, the Bernoulli. We'll study about binomial, and but Bernoulli is quite simple. We will take the reference of this from binomial itself. In fact, Poisson, normal, standard normal, uniform distribution. So these are the distributions that we'll talk about and that are useful for our case, in fact, useful for talking about. We can also talk about Bernoulli as well, in fact, that's totally fine. Okay, so that is what we'll be covering in the case of probability distribution so far. So just to talk about, so we talked about what is probability, okay, and what does it do, and but then post that, then we started talking about what are various applications of probability and how it is impacting various sectors, healthcare, banking, weather. Okay, and then we started talking about what are probability distributions. Okay, and what is experiment, and then how they are divided into further parts. Now we'll start going into detail, and that is how you'll be able to understand in detail also and much closely of what essentially probability distributions are. But yes, any questions anyone so far, please put in. Any questions, anyone? Okay, perfect. So let's move ahead. And now let's talk about yes, Sundar. Any other questions, anyone? Okay, then let's start. And let's start with the discrete probability distributions. Please give me a second. Okay, so discrete probability distributions. The first one that we'll be learning is Bernoulli. Now, first of all, for Bernoulli probability distribution, we need to know certain requirements that are there. Okay, there are certain requirements. What are those? Let's talk about that. First of all, this probability distribution models an experiment with exactly two possible outcomes. What are these two possible outcomes? One is success, usually denoted by P and also denoted by 1. And let me correct the spelling of success. Another one is failure. It is denoted by 1 minus P. Why 1 minus P? Can anyone think about it? What do you think, everyone? Correct, because probability is between 0 to 1. So if I'm saying the probability of success is P, so the probability of failure is simply 1 minus P. Correct. Okay. And the another requirement for Bernoulli probability distribution is that it only allows only one trial. Don't worry, as of now, if it's not clear, it will be in fact. This is the most simplest and you can say kind of understood without you knowing that you know Bernoulli distribution in fact. Okay, so it's very simple, but yes, from binomial is when you start getting interest and you start learning new things. But Bernoulli is kind of aware, you all are aware about it, but again, you do not know exactly what is Bernoulli. That is the only thing. But talking about this now, first of all, if I talk about a bit more on what these possible outcomes I'm trying to say, let me talk about these a bit. So if I talk about the success. Basically, and again, just to mention, these are user specified. Or let me write it down only. It is user specified. Okay, and it is labeled as P. Example, like what can be a success for our case? I can say example is getting head in a toss, of coin. You might say that okay, this is success as per a user, because if the user says if I get a head, it's a win for me. So that's a success. Like it's the user who defines it. So let's say getting a number less than 4 in a roll of dice. So all these, again, just to put one more example, getting 2 kings, you wanted to pull 2 cards and you were able to pull 2 kings. So if you get 2 kings, it's a success for you. So all these is what is a user defined, as I mentioned. So if you see getting 2 aces or 3 aces, that is what is a success. So it depends, okay, with respect to what your use case is. Now failure is opposite of success. It is determined by 1 minus p. Okay, 1 minus p. Why 1 again? And just if I write that thing now over here, and let me write p properly, it looks like a Greek symbol. So, okay, but why 1 minus p? Why 1 as the sum of probability as the sum of a probability of an experiment is always equal to 1. Okay, the same reason which I asked you. Okay, so that is why we call it 1 minus p, because if getting the probability of getting success is p, if I say the probability of getting uh, a success is p, so the probability of getting failure will be 1 minus p simply. Okay, now let's look into certain examples so that it's a bit more clear in fact. Let's see. Tossing a coin. Okay, and determining, like you say that okay, getting a head is a success for me. So in this case, what will be the calculations? So it will be like p for head, that is success, will be 1 by 2, that is 0.5. Okay, so basically what you can think of Bernoulli distribution as of now we are talking as a simple concept which is giving you names like what you are calling as success, what you are calling as failure. Okay, what is a trial? One now just to talk about this trial also, that you're only allowed to toss a coin once, Okay, like only one outcome is there. Only one time you're allowed to do experiment, one trial only. Okay, you're pulling card from the deck only once, or you're rolling a dice once. So that is this one trial is essentially referring to. So in plain terms, you can think of Bernoulli distribution. As I mentioned, you already know about it, but again, just formally putting it, and you're trying to understand the terms like success, failure, trials. Okay, so that is what it looks like for you as of now. But don't worry, as I mentioned, from binomial you'll start getting good. Second example could be rolling a dice less than or equal to 4. Less than or equal to 4. So now if I try to calculate the probability for this, so for a roll of dice, what are the possible numbers that can come as output? 1, 2, 3, 4, 5, and 6, correct? So if I calculate the probability of getting a head, probability of getting 1 is 1 by 6. Getting 2 and probability of getting 6 also is 1 by 6. Correct? Because every face is having equal probability. Do you agree? So chances of getting 1 divided by the total possible outcomes. That is how it is. Okay, so what is the chance of getting 1? Only 1. How many possible outcomes can be there? 6. That's why probability of getting 1 on a roll of dice is 1 by 6. That is why probability of getting 2 on a roll of dice is 1 by 6. Okay. Now, if in our case we are looking for calculating the probability for success. So probability of success. What is success for us? Success for us is getting a number less than or equal to 4. Correct? So probability of success will be so this is the probability of getting 1, probability of getting 2, probability of getting 3, 4, like this. Okay. Hence, if you add this up, it's 4 by 6 or 2 by 3. Or if you do the calculation, 0.666. Okay. So that is what the probability will look like. Clear so far, everyone? So what is the probability of failure now? 1 by 6 plus 1 by 6. And these are probabilities of what? Probability of getting a 5 and probability of getting a 6. Correct? Simple basics is what we are doing as of now, just so that it refreshes your memory about probability and those things. But I can write it this way also, 1 minus probability of success. So 1 minus 4 by 6. It will come out to be what? 2 by 6, correct? And if you say it's 1 by 3, that is equal to 0.3333. Clear, everyone? So does it make sense? Any questions, anyone so far? Please give me a second, everyone. Okay. So now see, this is quite simple. We were able to calculate it by hand, correct? So what we just to give you a recap, we started talking about the probabilities, okay, and what is a probability and how it is kind of used in every particular sector, from sports to weather to healthcare to any sector that you can think about. Probability can be used. Then we started talking about probability distributions. What is a probability distribution? Probability distribution in plain terms is a formula that can tell you the probability of all the possible outcomes that are going to happen based on an experiment. Okay, so think of probability distribution is how the probability is distributed with respect to every outcome. That okay, for this outcome, this is a probability, for this outcome, this is a probability, for this outcome, this is a probability, for this outcome, this is a probability. So how is the probability distributed with respect to all the outcomes? That is why we are calling it as probability distribution, or in plain terms, a formula that gives you the probability for all the possible outcomes from an experiment. Now they are divided into two: discrete and continuous probability distribution. So of course it's based on data. That if your data is discrete, so it will be following a discrete probability distribution. If your data is continuous, it will follow a continuous probability distribution. Some examples of discrete are Bernoulli, binomial, Poisson, hypergeometric, and as I mentioned, it keeps on going. And some of the examples for continuous are normal, standard normal, uniform, exponential, bimodal, multimodal, com, batch, and it keeps on going. And we'll be talking few of them. So we started talking about discrete probability distributions, where we started with the first and the most simplest probability distribution, the Bernoulli probability distribution. So Bernoulli probability distribution only comes in picture if you are having an experiment which only has two possible outcomes. If there are more than two possible outcomes, then Bernoulli probability distribution will not be applicable in that case. Okay, so this is the first requirement, that it is only applicable when there are two possible outcomes. The second one is that there is only one trial. So only for one throw, one toss, one pull is, if it's only happening for one time, Bernoulli is applicable. And because it is only happening one time, it's very easy for us humans to calculate all the probabilities that can happen. So that is why, for example, if I ask you what is the probability of getting a king from the card of deck, if I pull one card, it's very easy for you to calculate, correct? Why? Because we are only doing one trial. But what if I do it 4 times, 10 times? So it becomes difficult for you. Right? So that is why I was saying that Bernoulli probability distribution is kind of familiar to all of you, without knowing it, in case if you are not aware about it. But if you are only doing one trial, it follows the Bernoulli probability distribution. Two possible outcomes, success and failure, which are user determined. For example, what is a success? Again, as I mentioned, user defined. And you can say that, okay, if I toss a coin and if I get a head, So I'll call this as success. If I roll a dice and getting a number, you can decide it. Okay, I'll call this as a success. For example, getting 4 or less than 4, you'll say that okay, this is success for me. So you are the one who decides it. Getting two kings randomly from a card out app, you can kind of call that a success. So it's simply user defined. And what is failure? Simply opposite of success. That is 1 minus p. Okay, why 1 minus? Because the sum of probabilities of an experimental is always equal to 1. That's why 1 minus p. Okay. Now then we started looking into some of the examples which already all of you can do. In fact, what if I toss a coin? I do an experiment. So what is the possible outcomes? Two possible outcomes, head and tail. For me, if I say head is success, so I can say that okay, probability of success is 1 divided by 2. Why 2? Because two possible outcomes. Why 1? Because head can only appear or tail can only appear. Correct? Only one outcome can happen. So 1 divided by 2, 0.5. Same way when you roll a dice and you say that for me the success is getting a number less than 4 or equal to 4. So what are the possible outcomes? 6. And for every number, the probability is 1 by 6, 2 by 1 by 6, 1 by 6, correct? And if I calculate the probability of getting a number 4 or less, it becomes 4 by 6. Why? Because I simply is adding up all the probabilities of all the numbers. That is how I'm getting this, which is 0.6666. And for others, 0.3333. So far clear to everyone? Okay, perfect. Now, let's talk about this in a bit more standardized format. When I say standardized format, see, we all uh, can do this, correct? But what if we have a formula? What if we have a formula? Well, let's do one thing. Let's go to binomial because that is where the formula actually makes sense. In fact, not in the Bernoulli part. But I hope you're clear about what Bernoulli probability distribution is. So we have simply given a name to the thing which we already know. That if there is one trial, two possible outcomes, we simply call it Bernoulli. And if there are multiple trials, multiple uh, trials are there, so we call it simply binomial probability distribution. And that is what we'll be talking about right now, in fact. Okay. So let's look into this now. So we are starting with the second probability distribution. Let me see what color did I use for writing Bernoulli. Okay. Now there are certain requirements for binomial as well. And this is from where you'll start, you'll be able to relate things how they really make sense, in fact. Okay. So first, it is based on multiple trials. It is based on multiple Bernoulli trials. Like if I try to put it very clearly, your question would be, what is a Bernoulli trial? That is only two possible outcomes. that is failure and success. Okay, only two possible outcomes, which was the case with Bernoulli. The only difference majorly is that in Bernoulli you can only have one trial, but here you can have multiple trials. Here you can have multiple trials. Okay. So the second requirement is probability of success and failure. Let me take this a bit down. Remains constant at each trial. What do I mean by this? Means, just to talk about this, that it remains constant. What is this meaning? Let's say you're tossing a coin 5 times. Okay. Now my question to you is, will the probability of getting head at fourth outcome be impacted if I get a tail at the first outcome? What do you think? Means, will the probability of getting a head at fourth outcome be different compared to will be different if I get a tail in the initial three? What do you think? So the answer is no, correct? So what it says that after every toss, the probability of head and tail should be same. Like this is an example, just giving you an example, okay? Should be same, and that is same in fact, okay? But again, with respect to all the experiments, the probability remains same. For example, let's say you're having a bag, okay, in which there are three blue balls and three white balls. Now, in the first draw, you are able to pull out one white ball. Now, will the probability of getting white ball in the second trial change, or will it be exactly same what it was in the first trial? What do you think? So it will change, correct? I hope I'm audible to everyone. Hence, I can say that probability of getting a head should be equal to getting probability of getting a head, let's say at fifth trial, and at first trial. So probability of getting a head at first trial should be equal to the probability of getting head at fifth trial. Means, doesn't matter how many trials you are having, the probability of outcomes or the probability of getting outcomes will not change. Means, probability of getting head will not change, probability of getting tail will not change. Okay. Then I talked about an example where it will change. For example, you are having a ball. That is the example I took. Three blue balls, one white ball. You took first trial and you pulled out a white ball and you did not put it back. Now in the second trial, the probability has changed, correct? Probability of getting a white ball and blue ball has changed now. So that is when it changes. and that is where the binomial probability distribution will not be applicable. Okay. That is where the binomial probability distribution will not be applicable. So where it will be applicable? When there are multiple trials, and at every trial, the probability of outcomes remains the same. Example, toss of a coin, it will be always 0.5 for head, 0.5 for tail, at any outcome, at any trial, second trial, 2000 trial, or a millionth trial, it will always remain the same. Correct? So this is the second requirement for binomial probability distribution. Now the third one is all the trials should be independent. What does this say? That, for example, if you're tossing a coin 2000 times, it's not that the outcome of the trial 3 is dependent upon outcome of trial 2. Outcome of trial 2 is dependent upon outcome of trial 1. All the trials are completely independent. They do not have any linkage or any effect on each other. That is what this means essentially. Okay. And the fourth requirement is that there has to be a limited number of trials. There has to be a limited number of trials. Okay. That is what is the fourth requirement. For example, now see, you might be thinking that you mentioned there can be multiple trials. Yes, there can be multiple trials, but they have to be limited, like 100 or 200. Like how many trials? 2000 trials, one trial, sorry, or two trials, five trials. How many trials essentially? Okay, how many trials? So example, when I say limited, what do I mean by this? Tossing a coin 10 times. So this 10 is what I'm referring to. Or 800 times or 1000 times. Okay, this is what I'm referring to. So far clear to everyone? Now let's take an example of this and try to see how binomial probability distribution helps us. Let's see example. You are tossing a coin 3 times. Okay. So what is the probability of getting 3 heads? So if I write down all the possible outcomes, let's do that in fact. So let's see all the possible outcomes of tossing a coin 3 times. Let's manually write that. And that is where these distributions will help you. You do not have to think about all the possible outcomes. If you say that, okay, I want to simply get the probability, it will help you to calculate that. And that is what we'll be looking into in fact. So the first one is, let's say, head, head, head. Let's say this is the first one. Again, how many heads? 3 heads. The second one is head, head, tail. 2 heads. Correct? Third one could be head, head, sorry. Now let's make all the combinations of this only. Head, tail, head. Again 2 heads. Tail, head, head. Again 2 heads. Correct? Now, so I think we have got all the possible outcomes of getting 2 heads, getting all the 3 heads. Now let's look into chances of getting 1 head. So head, tail, tail, 1 head. Tail, head, head, again 1 head. Sorry, tail, head, tail, again 1 head. And tail, tail, head, again 1 head. So I think we have got all the combinations for this as well. Now and finally, the 8th one is tail, tail, tail. That is 0 heads. So these are all the possible outcomes that can come from tossing a coin 3 times. What do you think, everyone? Am I correct? Am I wrong? Did I miss any outcome? Have a look at it. Correct. Only these are the possible outcomes. What do you say, everyone? Now, if I try to calculate the probability of all these cases, that is 0 head. So what is the probability of this case to happen? 1 by 8, because I can see only one cases where there is no head. Correct? So 1 by 8. Probability of getting 1 head is how much? 3 by 8. Correct? Probability of getting 2 head, how much? 3 by 8 again. Correct? Probability of getting 3 heads, again 1 by 8. And this captures all the possible outcomes. And you can write it reverse as well. If I try to write it reverse way, you can write it in reverse method also, like 3 heads. Sorry, 3 tails. Okay. 2 tails, 1 tail, 0 tail. Correct? What do you say? Means what we have done is we have calculated the probability for all these cases, and if I write this down, so this could be 0.125. So same would be the case for this also, 0.125. For this it would be 0.0375, if I'm not wrong. And for this also it will be in the same 0.375. Okay. So what we were doing is we started talking about the binomial distribution, and I mentioned that it only has it can only be applicable when there are multiple tries, but multiple Bernoulli tries which have only 2 possible outcomes, and thus probability remains the same. Tries are independent, but there are limited number of tries. Then we started looking into this example, and from this example only is where I'll build the whole story for you. That for example, you are tossing a coin 3 times, so what is the probability of getting 3 heads? So what we did, we manually wrote all the possible outcomes down and manually calculated the probability. We manually calculated the probability. But what if I say to you, and we were able to get the answer that, okay, what is the probability of getting 3 heads? So for us, this is the answer. That will give the probability of getting 3 heads is 0.125. So this is the answer for us. Okay. Now, what if someone says that okay, you are tossing a coin 300 times? So what if the toss is 300 times? Now, can you calculate the all probability for? Can you calculate first of all the possible outcomes? Can you write down all the possible outcomes? That will be very difficult. Correct? Very difficult to do it manually. Okay. But just to also talk about, see, can I say, and we know this now, can I say that these are all the possible outcomes? You mentioned this to us. Yes, like these are all the possible outcomes. Can I say that for all the possible outcomes, I have calculated the probability? So this is what is a probability distribution. That how is probability distributed? How is probability distributed? If I try to make a graph, this is how it will look. For example, if I just make a simple graph, in fact, just give me a second. I can see, for example, 0 head, 1 head, 2 head, 3 head. Correct? If I try to make a graph on top of this, it will look like this. Correct? Like this. What do you say? Do you agree? So can I tell from this graph how is the probability distributed across various outcomes? So this is essentially what is a probability distribution. This is what is a probability distribution. Clear to everyone? What is not clear, Toby? Which particular part? See, what is the name? First of all, look at the name. What is the name? Name is probability distribution. How is probability distributed? Now your question would be distributed across what? Distributed across outcomes. Correct? Distributed across outcomes. So we took an example that okay, what if you're tossing a coin 3 times? What is the probability distribution? Let's even forget this. If I say if you're tossing a coin 3 times, what is the probability distribution? If I try to write this, so what is the probability distribution? So what you did, you manually wrote down all the possible outcomes and calculated the probability manually. So this is what you're doing, you're calculating the probability distribution. How is the 2 tail and 1 head, 3 bite and 1 head? Okay. Two tail. See, first of all, do not get confused with this. This is, I was telling that you can write it this way as well. I think you have got confused. You're getting 1 tail and 3 heads. That is not possible. So now this might help you understand. So the probability of getting 1 head, exactly 1 head. When are we getting only 1 head? 1 head is only possible in this case, and this case. How many outcomes total? 3. How many total number of outcomes? 8. Because all these are possible outcomes. So 8 number of possible outcomes. In how many outcomes are we getting 1 head? Only in 3 outcomes. Hence 3 by 8 for 1 head. Same way, in how many outcomes we are getting 2 heads? 1, 2, and 3. So 3 outcomes when we are getting 2 heads. How many possible outcomes? 8. Hence 3 by 8. Does it make sense now? Now I can also call 0 heads is equal to 3 tails. Can I say that? Like also call as, okay, 3 heads. Sorry, 3 tails. That is what I was referring to. So this is what is probability distribution, that for all the possible outcomes you are seeing how the probability is distributed, hence probability distribution. Okay. Then I put up a question, what if there are 300 times you are tossing a coin? Will it be easy for you or difficult? It becomes difficult to do it manually, correct? So hence we'll be looking into multiple things in tomorrow's class. And let's suppose over here we'll start looking into the probability mass functions, how to look into tables, and so such kind of things. That is what we'll be doing in tomorrow's class. But yes, this is what I wanted to discuss in today's class. We'll continue from here only in tomorrow's class on the example of doing 300 tosses. Okay. So any questions, anyone, please put in. And in case if no questions, I have shared the feedback link with everyone in the chat. Request you to please provide the feedback and then you can drop from the class. Only 5 is termed as good in the feedback. Other than 5 is not termed as good. You can provide in your comments as well. And those who are dropping, thank you. See you tomorrow. Now, in case if you have any questions, please put in your questions. Then you can provide the feedback and drop. Thank you, Manoj. Thank you, Prajita. Can you give any use case to work on? For project work, Bharat, I think you're referring to, correct? You can, what you can do is you can try to solve the capstone projects that are present in your this particular course. So the course and projects is what you can try to solve, Bharat. That is where you can look into multiple things. So there are already use cases that are present in your course itself. Okay. Thanks, Aprajita, Abhay, Yukinder, Sundar, Toby. Thank you, Vasu, Bharat, Abhishek, Atla, Altaf, Jaya. Thank you, Syed. So I do not see any questions coming up. So thank you, everyone. See you in tomorrow's class where we'll be discussing these probability distributions in detail. Yes, Lakshmi, have you installed Zoom in your system? We can look into that if you want to. Are you there, Lakshmi? I'm not sure Lakshmi is there. So no issues. So thank you, everyone. See you in tomorrow's class. Thank you, everyone.
Thank you for a wonderful session, Rahul, and thank you for everyone for your participation. Once we wrap up the session, you can see survey feedback from in your browser. Please rate us the session between 5 or less than 5. It will improve the upcoming session. Thank you, everyone.